Today's lesson is on solving rate problems. First, we'll look at finding a distance. For number 1, a giraffe runs at 880 yards per minute. How far can it run in 3 minutes? We're going to use the formula D equals RT, where D is the distance, R is the speed, and T is the time. So our distance equals our speed times the time. Our question is, how far can it run in 3 minutes? So we do not know our distance. So we're going to have that equal to our speed, and our speed is 880 yards per minute. So we have 880 yards in 1 minute. And then we need to multiply that by t, or the time. And the time would be 3 minutes. So we'll multiply that by 3 minutes. We can go and write that over 1 to make it a fraction. Notice that we have minutes on the top and minutes on the bottom, so those will cancel out. And now we need to multiply across. We have 880 times 3. So we'll do 880 times 3. And 3 times 0 is 3. 3 times 8 is 24. 3 times 8 is 24. Plus 2 is 26. So 880 times 3 is 2,640. On the bottom, we just have 1 times 1, which is 1. And if we divide this by 1, we'll get the same thing. And then our label we have is yards. So our distance is equal to 2,640 yards. Next, we're going to look at finding a speed. So for number 2, a lion runs 288 feet in 4 seconds. What is its speed? We're going to use the formula R equals D divided by T. R, again, is our speed. D is the distance. And T is the time. So we do not know the speed. So we do not know R. So we have R equals D is our distance. The lion is running 288 feet. So we have 288 feet. And then we divide that by the time. And it's doing that in 4 seconds. Now we need to go ahead and divide 288 by 4. So 288 divided by 4. 4 cannot go into 2, so we'll see how many times 4 can go into 28. And it goes in 7 times, and 7 times 4 is 28. And then we subtract, and we get 0. And then we bring down the 8. And 4 goes into 8 2 times. 2 times 4 is 8. We subtract and we get 0. So 288 divided by 4 is 72. So we get 72. And then we still have our label. And our label would be feet per second. So we have feet per second. And that would be equal to R. So our speed is 72 feet per second. Now we're going to look at solving a rate problem. So for number 3, a hot air balloon rises 8 meters every 4 seconds. How high does the hot air balloon rise in 20 seconds? We're going to use 2 different methods to solve this problem. First method we're going to use is a formula. We have the formula D equals RT. Remember that D equals the distance, R equals the speed, and T equals the time. We do not know our distance, so we're going to start with our speed, and our speed is 8 meters every 4 seconds. So we have 8 meters, and that's every 4 seconds. And then we need to multiply this by the time, and we're multiplying this by 20 seconds because we want to know how high it goes in 20 seconds. And that then can be over 1. Notice we have seconds on the top of the second fraction and seconds on the bottom of the first, so those will cancel out. We can also simplify the 4 and the 20. We can divide both of those by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. Now we can go ahead and multiply. 8 times 5 is 40. And on the bottom we have 1 times 1, which is just 1, so we don't need to worry about that. And then we need to label it, and our label that's left is meters. So how high does the hot air balloon rise in 20 seconds? And the answer would be 40 meters. We can also use a different method to solve this problem, so let's use a different method. The other method we can use is by doing a unit rate. So the first method was a formula, this method is a unit rate. So let's go ahead and start with our rate that we have. It's 8 meters. And we do that in 4 seconds. Remember, to find a unit rate, we want to know how far we go in 1 second. If we go from 4 to 1, we are dividing by 4. So on the top then, we'd also divide by 4. And 8 divided by 4 is 2. So we have 2 meters. So our unit rate is 2 meters per second. So if we go 2 meters per second, and then we want to know how far we're going to go. If we go 20 seconds, we'd multiply that by 20 seconds. Our seconds would cancel out. So then we'd multiply 2 times 20, which is 40. 1 times 1 is 1, so if we divide by 1, we still have 40. And then our label that we have left is meters. Notice that we got the same thing both times. The first time we did a formula, D equals RT, and the second time we did a unit rate. We changed 8 meters in 4 seconds to 2 meters per second to help us solve the problem. Now we're going to solve a cost problem. So for number 4, we have 5 cans of soup cost $6. How much do 7 cans of soup cost? So first we know that we have 5 cans of soup, and that's going to cost us $6. So it's $6 for 5 cans. We want to know how much it costs per can. So we can go ahead and do a unit rate. We just want to know 1 can. So we're going to divide by 5 in the denominator, so we go from 5 to 1, so we need to divide by 5 in the numerator. So now we need to do 6 divided by 5. 5 goes into 6 one time, and 1 times 5 is 5. We subtract and we get 1. Now we need to add our decimal and our 0 and bring that 0 down. We also need to remember to put our decimal in our answer as well. Now 5 goes into 10 2 times, and 2 times 5 is 10. We subtract and we get 0. So we get 1.2. Since we're talking about money, we need to add a 0 behind the 2. So we add another digit behind the 2 so that this is correct for money. So it would be $1.20 per can. So we found the unit rate as $1.20 per can. Now we need to figure out how much 7 cans cost. So if we know it's $1.20 for 1 can, We can then multiply that by 7 cans to see how much it will cost for 7. We can do a 1 underneath the 7 cans to make it a fraction. We will cancel out the cans, the label, and then we need to multiply $1.20 times 7. So $1.20 times 7. 7 times 0 is 0. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. Our decimal is 1, 2 places over, so we'll go over 1, 2. So we get that 7 cans cost $8.40. Notice that we multiply the bottom, we have 1 times 1, so if we divide by 1, we're still going to get $8.40.